we move on to an equally challenging issue around the human right to education. And this is closely linked to the United Nations Sustainable Development Goals, guiding us to a better and more sustainable future for all. Addressing the global challenges we face, including poverty, inequality, climate change, economic degradation, peace and justice. And I'd like to welcome Professor Richard Murphy to introduce his PhD student, Anna Andries, to talk about her work, which contributes to achieving goal number 4, which is the provision of quality education.
Thank you, Patrick. Your Royal Highness, it's a real pleasure to introduce Anna Andries and her PhD research to you. Anna's studies are being supervised by me and my colleagues at Surrey's Centre for Environment and Sustainability. This is in partnership with the National Physical Laboratory at Teddington and with support from the Natural Environment Research Council's Scenario Doctoral Training Partnership. Surrey is very well known for satellite technology. Anna's innovative research as part of our Space for Sustainability initiative is now harnessing the power of satellite Earth observation for the benefit of sustainable development, both here and globally. Anna, over to you.
Thank you so much for the introduction. Good afternoon, everyone. I'm Anna Andries, and I'm doing a PhD research in using satellite data for sustainable development goals. And one of the case studies that I'm presenting today is how to identify overcrowding in rural schools in Nigeria. Nigeria is first 4 nations in the world with the highest number of overcrowded schools. And why this is a huge issue? Mostly because overcrowding can affect the learning process and academic achievements of nearly 25 million learners. What can we do and how can we identify the overcrowding schools in a more effective way? So instead of relying on the indicator teacher-pupil ratio that normally Nigerian government uses to measure the pupil density in school, we use satellite images to measure the footprint area of the classroom buildings. So when the total size of the buildings measured was divided by the total number of the pupils, we obtained the area in the square meter attributed for a pupil. Therefore, in a graph on the right-hand side are illustrated our results. So we can see the distribution of the area per pupil in 1,900 public schools. And on the left side of the red line, we found that 71% of the schools measured have less space per pupil than the minimum standard of 1.2 meters square. Hence, they are considered overcrowded. So satellites in Earth observation has allowed us to rapidly identify the overcrowded schools. Next slide, please. So the finding of this study highlight a critical barrier towards achieving universal basic education and sustainable development goal for quality education in Nigeria. But in a wider context of my PhD research, we developed a framework that assesses the full potential of satellite data to support other sustainable development goals, such Goal 1, ending poverty, Goal 6, clean water, Goal 13, climate change, and so forth. Next slide, please. So this framework was well received in the literature. And if you would like to know more about this, please feel free to scan the QR code. We have also used very high resolution satellite data in a local test and trial project alongside with Defra for monitoring biodiversity, enhancing soil organic carbon sequestration, and assessing public access in Surrey Hills area of outstanding natural beauty. Moreover, we established an approach that supports fair and even development via nighttime satellite data in Romania and other European countries. I would like to close saying that the main benefits of using satellite data are its reliability, free from bias, and it is an easy, timely monitoring tool. Thank you for your attention.
Anna, thank you very much. I should say that the technology that allows for Earth observation comes out of one of Surrey's pioneering pieces of work in space and satellite technology. And indeed, Surrey Satellite Technology Limited was a spin out from the university and sits on the same research park as the Kate Granger building.
Yes.
Thank you very much. That was really fascinating, because I've travelled to many countries, but and particularly mainly to do with eye health programs, but obviously childhood education and women involved in peace and security is something that I'm very heavily involved in. So it's actually really interesting seeing how this is all part and parcel of the same thing of trying to ensure that countries that are signing up to sustainable goals through UN programs and everything, they can be held accountable if you're able to show that if a country is saying, yes, we are giving children access to education, there's ticking a box and there's being effective, and the two are very, very different things. And if you're actually able to provide physical evidence without actually having to send large numbers of people out onto the ground to do mass programs to research and travel round and turn up with clipboards and write things down, you can do it very effectively from space. And as you say, it's totally fair. Nobody's trying to slew anything. You're seeing what you're seeing, but people can make informed decisions based on that technology. And how fascinating that you're doing it in so many different areas as well. It's brilliant. It's wonderful. Very exciting.
Thank you so much. Thank you.
Good luck.
Thank you so much. Yeah.
Anna, Richard, thank you very much. Finally, in this particular section, we'd like to move on to address the issue of energy poverty. In a world where energy is free, then the opportunity